Okay, just one other little thing on circles, which is something that I think could well come up in your test, because if I was writing the test, I'd put it in, to be honest. Now, this is a lush little question, and I think you're going to really like it, but if you saw it in the exam, I suspect you'd all panic a little bit. So let's just have a little look. So I'm going to draw a circle, okay, and I'm going to put my diameter in, my radius in. I'm going to have it as 3 centimetres. Okay, and I'm going to draw myself a right-angled triangle. Okay, so you could get a question where you've got a circle with a right-angled triangle in it like this. Now, it might have the right angle in it, but it might also just show that this is 3 and this is 3. If this is 3 and this is 3, it must be a right-angled triangle. Okay, so if these numbers are the same, it must be a right-angled triangle. Now, what it might ask you to do is it might ask you to calculate the area of this shaded bit here. And this is called a segment. And I don't think we've done segments, but they might just say calculate the area of this shaded bit here. Okay. Now, if you were to look at that without me showing you this, you'd probably panic and think I can't possibly do it. But actually, you know everything you need to know to be able to work out what this little segment area here is. Okay, but this is where you need to kind of combine two different areas of mathematics in order to do the problem solving. So the first thing we're going to do is we're going to actually calculate the area of this whole piece, including this segment and this triangle. Okay. So the first thing we're going to do is we are going to calculate the area of this whole circle. So we remember that the area equals pi r squared, and the r squared is 9, so 3 times 3 is 9, so we've got pi times 9, and I'm going to pop that into my calculator. So I've got, turn it on. Pi times 9 is going to be 28.2743. So 28.2743 centimetres squared is the area of this whole circle. Now remember, I'm calculating the area of this whole bit. It's 90 degrees, so it's going to be a quarter. So I'm just going to do 28.2743 divided by 4. Now, if we look back to our little example we did up here, we did 95 over 360. If you wanted to keep it consistent, you could simply do 90 divided by 360, okay? It would give you the exact same thing, because 90 is a quarter of 360. So it's up to you if you just want to keep it consistent. So if I divide here by 4, the area of this whole quarter of my circle is 70.6858. So, sorry, 7.0688 centimetres squared. Okay, so that's the first thing that we need to do. Now, the second thing we want to do is we want to calculate the area of this triangle here. So we know how to calculate the area of this triangle here, because it's just simply the area of a triangle. So we do 3 times 3, which is 9, and then it's a triangle, so we need to divide that by 2, and 9 divided by 2, not even I need a calculator for that, is 4.5 centimetres squared. So 3 times 3 gives me 9, divide that by 2, because I only want half of it, 4.5 centimetres squared. Now, this is the cool bit. I now know the area of this bit, okay? This is my bit in red here, the area of the triangle. I also know the area of my segment, which is the bit in green here. So now, to find just this bit in here, all I simply need to do is take away the red bit, so the area of the triangle, away from the green bit, the area of that whole segment, and that's going to give me just this little shaded bit here. So I'm going to do 7.06858, take away 4.5, and that is going to give me the area of that little segment, which is going to be 2.56858, and I'm going to do 3 significant figures again, which is 2.5. This time, this 8 is going to make this go up 1, so I'm going to have 2.5 7 centimetres square. Right, now, you'd look at that question and panic, but actually it's so easy. It's the area of a triangle and the area of a segment, which is just a nice little question if that comes up. Okay, now, other thing tonight is that you could have something like this coming up in like a cylinder. So you could have it coming up in my drawing's rubbish, as you know, or a cone. Let's do a cone because I'm a bit rubbish at drawing a cylinder. So just remember, if you've got something like this and you can see in there, in the dimensions that it's sort of sketched in, a right angle triangle, just think whether there are other things that you might need to bring into the equation, okay? I'm going to show you one more little challenge question as well. So let's have a look at that. Okay, so it's a cheeky challenge too, so let's have a little look how this one might work. Now, I've drawn it quite badly, but just roll with me on this. So I've got my circle, I've got my radius in of 3 centimetres on each side, and I've got my line drawing up here. Now, we could have a situation where it might want us to have the length of the outside of this shape, and I'm going to go over that in a different colour. So when I said the outside of this shape, and I'm going to do it like this just so you can see. So instead of having the whole circumference, this little green bit here, it might want us to have this bit here instead, okay? So it might say, show the area of the shape that's shaded, and this might be in a dotted line or something like this. Now again, you need to sort of bring in 2 topics together to help you do this. So the first thing, as soon as we know they're talking about the outside and there's a circle, we know that we want pi times diameter. And again, we want pi times 3 times 2, yeah? Because we've got the radius and we want the diameter, so we need to multiply by 2. So we've got pi times 6, which if I pop that in my calculator, is going to give me 18.849555 ... Okay? So pi times 6, that gives me that many centimetres, and that gives me the whole piece of this circle. Forgot my words then. Okay, and remember in here we've got the right angle. So, the first thing we need to do the second thing we need to do is we need to make sure that we take away this part here. Okay, now this part here, because it's 90 degrees, the same rules apply as we did in the earlier example. So we want to take away 1/4 of this number, or we want to keep 3/4. So I'm going to do 18.849 ... and I'm going to times it by 3/4 because I want to keep 3/4 of it. Okay, I want to get rid of 90, keep 270. So I'm going to times it by 3 and then divide by 4, which is going to give me 14.1371669 centimetres. Okay, so this then gives me this whole piece around here, around here, around here to here. But I still need to add this bit in, and this is where it gets funky because we can use Pythagoras to help us work out the length of this side here. So if we pop into our little back of our brains and pull out our Pythagoras theorem, we know that a squared plus b squared equals c squared. And remember, we must always label our longest side and the side opposite the right angle as side C, sorry. So I've got 3 squared plus 3 squared equals c squared. So I've got 9 plus 9 equals c squared. So I've got 18 equals c squared. So the square root of 18 is going to equal c. So if I do square root 18 on my calculator, I've got 4.2426 equals to c. So I now know that this length here is equal to 4.2426, and all I simply need to do now, and this is where I get very excited, this is my bit that we said was from around here to here, and this is my bit that we said was from here to here. So I'm just going to add those two together. So 14.137166, etc., etc. Add that together, 14.13716 gives me 18.3798, and I'm going to do that to three significant figures. So I've got 18.4 centimetres. Again, if you looked at this question, you'd probably panic and not be able to do it, but actually just break it down, look at the question and look at the things you recognise. If you've got a circle, are you calculating the area? Are you calculating the circumference? Has it chopped a bit off? What's the fraction that it's chopped off? Has it added a bit on? How can I work out what bit it's added on? But just don't panic when you see these sorts of questions, okay? You can do them.